Okay, in this video, we will talk about the phasor diagram. What is a phasor diagram? A phasor diagram, a phasor is a vector of constant magnitude and rotating in an anti-clockwise direction with a constant angular velocity omega. When it rotates, it generates a waveform. Okay, so now I want to introduce you to the four different functions that you will see very frequently. The first one is the positive sign function. The phasor should look like this. Remember, the phasor will rotate anti-clockwise, and then we only consider the height of the phasor. That means that, okay, you see how the phasor rotates and how it generates the waveform here. When it rotates like this, it will generate this sine function. So by the same reasoning, for example, for the positive cosine function, it is like this. For the negative sine function, it's like this. For the negative cosine function, it's like this. Okay, so you really need to know this is sine function by just looking at this graph. You also need to know this is a cosine function by just looking at this graph. If possible, if you can remember the phasor diagram for a positive sine function looks like this, or if you can remember the phasor diagram for the positive cosine function is like this, then it will be better for you. Remember, the positive sine function is like this. If all the positive value becomes the negative value, if all the negative value becomes the positive value, then it becomes the negative sine function. The same goes to this. This is positive cosine function. If you make sure all the positive value becomes the negative value and all the negative value becomes the positive value, it will become the negative cosine function. Promise me something. In one cycle, you have 2 pi radian. If possible, please write your answer clearly, because for some students, normally they write 2 pi, they don't write 2 pi radian. And when the worst come to the worst, they even write 2 pi degree. Because 2 pi degree is just equal to 6.28 degree. But then 2 pi radian is equivalent to 360 degree, 360 degrees. They are totally different. So when you are using the pi, when you are using 2 pi, you know that it's in the form of radian. It is never in the form of degree. Okay? Okay, so let's summarize what you have learned. This is positive sine function. This is positive cosine function. This is negative sine function. This is negative cosine function. And then it is rotating in anti-clockwise direction. Assume that you are here and then you are running here. And then your friend is here and your friend is running here. You know that your friend is leading you, and then you are lagging behind your friend. So you know that negative sine function leads positive cosine function by 90 degree or pi over 2 radian. Negative cosine function leads negative sine function by 90 degree. Positive sine function leads negative cosine function by 90 degrees. Positive cosine function leads positive sine function by 90 degrees. Okay? 90 degrees is equivalent to pi over 2 radian. So by seeing the graph like this, for example, when the voltage is 0, current is 0. When the voltage is maximum, current is also maximum. When the voltage is 0, the current is also 0. When the voltage is the most negative value, the current also has the most negative value. So that means that voltage and current are in phase. Okay. The x-axis is time. So you know that when they have made one oscillation, it is 1 period. Okay, for this, the V reaches the peak value before the I. The V reaches 0 before I. So you know that V leads I by 90 degree or pi over 2 radian. In fact, this is positive sine function. This is negative cosine function. So just now you have already learned what? You learned that positive sine function leads negative cosine function by 90 degree. So you know that V leads I by 90 degree. For this case, I leads V by 90 degree. And then you have to remember that because this is a combined graph, that means that the unit for current is ampere. The unit for voltage is V. Of course, the y-axis, they have to be in different scales. So you don't care about the amplitudes. You only care about the phase angle. Okay? And then, ultimately, you will learn that for this graph, when the V and I are in phase, it is resistor. For this graph, when the voltage leads current by 90 degree, it is inductor. When the I leads V by 90 degree, it is a capacitor. Okay, so in the following video, we will talk about the alternating current through a resistor, an inductor, and a capacitor respectively. Thank you.